The lesson outcome for this video is, I can factor quadratic expressions when a equals 1. So the first thing I want to talk about quick here is, what is a quadratic expression? Well, as you can see here, we have an expression, and we've just been talking recently in class about information about this expression. First of all, we know there are 3 terms, and we know that the degree of this polynomial is 2 because the highest exponent on a variable is 2. So if this is a degree 2 polynomial, it is called a quadratic. All right, so that's how we know this is quadratic, because we have an x squared. The other thing I want to talk about really quick is when a equals 1 is the only type of factoring we're going to be doing in this unit, and a is obviously this value right here, and that is always going to be a 1. And if you think about how if it was a 1 written right here, 1x squared, you probably remember that typically we don't have to write the 1 right there. So if I were to erase that, I can't actually, sorry. So if I were to erase that, it wouldn't be there because we don't have to write it in. We would just have an x squared at the beginning of our polynomial. All right? And so things in this form right here are quadratic expressions when a equals 1. More on that on the next screen. But before we do that, we're going to talk below here about how, also in the previous unit, we took a binomial times a binomial and we would multiply it out and find out what we would get. Well, we're going to do that right now. The first way I'm going to do it is using the FOIL method, and you should remember that from, again, our previous unit. First, outside, inside, last. So we need to multiply the first terms. That's x times x, and that gives us x squared. Then we need to multiply our outside terms, which is x times 7. So that's 7x. We're going to write plus 7x. Plus I, the inside terms, that's 4 times x, so 4x, so plus 4x. And then last, the L stands for last, and that's 4 times 7, which is 28. So once we got to this point, you probably remember that we would combine our like terms. We have an x squared term, there's no other x squared term. We have an x term, and there's another x term right here. So 7x's plus 4x's would be able to be simplified. So we have x squared plus 7 plus 4 is 11, so 11x plus 28. Now what you should probably notice here is that this, right now, what we just got, is a quadratic expression. It looks just like this right here. We've got our leading coefficient is a 1 because there's no number right there, because 1x times 1x is 1x squared. We didn't have to write that. And then we have a number here in front of x, and then we have a constant over here. So here's a quadratic expression we arrived at after foiling this problem. The same thing could have been done over here in our other method, the array. Okay, and again, doesn't matter which of these you use. And if we take the x and the 4 here, and then the x and the 7 here, and we multiply, x times x gives me x squared. And then x times 7 gives me 7x. 4 times x gives me 4x. And 4 times 7 gives me 28. Again, we have like terms, 4x and 7x, that can be combined. And so we end up with, again, x squared plus 11x plus 28. The same quadratic expression, trinomial, here, because it was the same multiplication problem. So if you think about how we arrived at this quadratic expression by multiplying two binomial factors, if we, again, remember, factors are when we multiply things together. So this is a factor times a factor. And when we multiply these two factors together, we got this. Well, factoring a quadratic expression is finding these two things that we multiplied together to get this in the first place. So you can kind of think of factoring quadratic expressions as undoing FOIL, or undoing the array, and finding out what factors multiplied together to give us this. Let's try some on the next screen. So this might look familiar. I used the exact same expression quadratic expression. It's a trinomial. And I'm going to show you the process of trying to take a quadratic expression and find out what are the two sets of parentheses going to be that would multiply together to get me this. Okay? So here's what we want to do. Here's our steps. We're going to start by, now if you remember from the previous screen, we had ax squared plus bx plus c, right? So c is this term out here. The first thing we're going to do is we're going to write that c term, the last term, the constant term, over here in this box. Now remember, if it's positive, make sure it's positive, which it is. If this was a negative, make sure you write in a negative. Now what we're going to do is we are going to list all of the factors of 28. So this is exactly what we've been practicing in our previous unit. 1 times 28, and 2 times 14, and 4 times 7 are the factors of 28. Our next step is to add our factor pairs. Okay, so I'm going to add, again, remember we got these by multiplying, so 28 is 1 times 28. Now I'm going to add them. Okay, what's 1 plus 28? Well, it's 29. What's 2 plus 14? Well, that's 16. And what's 4 plus 7? That's 11. What we need to do to find the factors that go into these parentheses so that if I multiply them I get to this, we need to find the factor pair that adds up to this middle b term right here. Okay, so which of these numbers here match this middle term of 11? Well, obviously this 11 right here, and therefore 4 and 7 are the numbers we need to put into our parentheses to list our factors. Okay, so what we're going to do is we're going to say, if I were going to FOIL this out, first, outside, inside, last, and arrive at this, what would I have to multiply here and here to get to x squared? Well, it's x times x. X times x will get us that x squared. Now, we're going to take the two terms right here that we found out they multiplied and gave me 28, this number, and they added to give me 11, which is this number. So we have to multiply to get this number and add to get this number, which are 4 and 7. So now we're going to put in plus 4 because 4 is positive, and plus 7 because the 7 is positive. We now have the factors that we started with on the previous screen. If, again, we FOIL it, we'd get x squared plus 7x plus 4x plus 28, right? X squared plus 7x plus 4x plus 28. Then we would combine the 7x and the 4x, which is 11x, and you'll notice that that is our quadratic expression right there. So our answer is x plus 4 times x plus 7. We have factored the quadratic expression. If that first example was a little confusing, that's okay at first. It just takes some practice. So let's try the second one. Again, we're going to take our constant term, which in this case is positive 14, and we're going to write that in this box. Now we're going to list all the factors of 14. 1 times 14 is 14, and 2 times 7 is 14. Are there any other factors of 14? No. Now we are going to add them. 1 plus 14 is 15, and 7 plus 2, or 2 plus 7, is 9. Okay, so once again, if you remember the question we had earlier, the question is, which of these factor pairs adds up to the number that appears right here? Well, you might be thinking 9, so it's 2 and 7. But that's not exactly correct, because this number is actually negative 9. And if it's negative 9, it means that we need this to be negative 9. In order for this to be negative 9, we would have to add negative 2 plus negative 7 to get negative 9, right? Well, that would actually be just fine, because what is negative 2 times negative 7. Well, negative 2 times negative 7 is positive 14. So these are still the two numbers that multiply to give us 14. They're still the factors that work to multiply to 14, and they are now the factors that add up to negative 9. And the negative 9 matches this negative 9, and therefore we can write our factors. X in the front of each set of parentheses. And now we're going to write a negative 2, so minus 2, and a negative 7. We took this number and put them in the parentheses. If we were to FOIL this to check, we would arrive at this. And I'm just going to do that one more time so that you see it. The first terms, multiplying the first terms, I'd get x squared. Multiplying the outside terms, I'd get negative 7x, right? X times negative 7. Negative 7x. Inside terms, these two terms multiply together is negative 2x. And the last terms, negative 2 times negative 7. Negative times negative is positive, and 2 times 7 is 14. Now if I combine my like terms, I will get x squared minus 9x plus 14, which is, again, the expression we started with. All right, let's try a couple more. The first one, we're going to put negative 12 into this box, which changes things up a little bit. Did you notice? That was a negative 12. If it's a negative 12, we need to multiply or list our factors of negative 12. Well, we know 1 times 12 is 12. But if I need it to be negative 12, I need to make one of these two numbers negative, but not both. I'm always going to just start with making the front one negative. We also know 2 times 6 is 12, but we need one of them to be negative, so I'm going to make it this one. And we know that 3 times 4 is 12, but again I need one of them to be negative, so like that one there. Again, I can move that negative to the other number, but both of them can't be negative in a factor pair because then that wouldn't multiply to be a negative 12, it would be positive. Now we're going to add our terms, our numbers. So negative 1 plus 12 is 11, negative 2 plus 6 is 4, and negative 3 plus 4 is 1. Which of these matches our middle term? Well, obviously this 4 right here. So we know our factors that we need to use are negative 2 and 6. So in the parentheses, we're going to write an x and a negative 2 and a positive 6. The last one. I'm going to write a negative 12 in the box. 1 times 12 is 12, and one of them has to be negative. Notice it's the same C term, but we have a different middle term. Same C term, but a different middle term. 2 times 6 is 12, but one of them has to be negative. And 3 times 4 is 12, but one of them has to be negative. When I add them, I get 11, 4, and 1. Okay, which of these numbers matches my middle term? Well, none of them right now, right? We have a positive 1 right here, but we need it to be a negative 1. And again, the way we get it to be a negative 1 is if we change this to a negative 1, it's because this one right here is actually going to be the negative 1, and this one is going to be the positive 1. So if you look, what's positive 3 plus negative 4? Well, that adds up to negative 1. So now that matches the middle term. So there's my factors. I need x plus 3, and I need x minus 4. If you're not catching on yet, that's okay. It takes some practice. We'll do so in class.